Row, row, row your boat gently down the stream. Merrily, 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 life is but a dream. Yep, no budget for theme song, so that is it. My name is Ohan, and this is Apes and Drapes. This episode is brought to you by dictionaries, carving reality out of the abstract space of thought in small, digestible pieces. Yes, dictionaries, the only places in the universe we can look to pretend things have meaning. Alright, here we go. What are we doing? Meaning, since we can recognize our own existence, why continue this human experiment? Why have children if we do not consider our children's children and theirs, and so on? What happens if we actually start to think about why we continue to exist? If we exist for the present moment, then so be it. But then we can't also pretend that we care about our children. To care about our children means to care about their children, because our children will love them more than they love us. And if we love them more than we love ourselves, we have to love our children's children, if only for our love for them. So, what kind of world will they inhabit? Surely this must make us consider the state of nature, reserves of water, biodiversity, the state of the oceans. But I don't want to talk about the next 50 or 100 years. We've covered the need to focus on sustainability in previous episodes. I'm interested in the next 1,000, the next 10,000, 100,000, 1 million years into the future. Sure, we care less and less about our descendants past a couple of generations. They begin to become random people. But then why lie to ourselves and pretend our love for our children is anything but really our love for ourselves, and that our desire to have children is really only an attempt to provide ourselves with a sense of purpose? That question is for another episode. This episode's not about that either. The Earth has a limited lifespan regardless of what we do with our lives, about 5 billion years. And before that, the surface of the Earth, with regard to its habitability for life, has an even shorter lifespan, about 1 billion years. And before that, as soon as within the next 10 to 50,000 years, we have to deal with rising tides, a coming ice age, and increasingly greater potential for massive volcanic eruptions, earthquakes, and meteor impacts. Beyond all those things, the lifespan of our solar system is limited, the lifespan of our galaxy is limited, the lifespan of every sun in our universe is limited. So, what on earth are we doing on Earth? Why not simply live excessively in the now and just die out? Here's the thing. Why continue to exist if our defeat is certain? For the record, my vote is to continue onward in spite of the coming oblivion. But in order to hold any opinion at all, we have to consider the actual circumstances. Otherwise, our opinions have no value. We have to consider what it is that is valuable about us in the first place, or we have to admit that this entire exercise of existence is one pathetic, masturbatory denial of self-indulgence. I think there is a purpose we can grant to our existence that isn't pointless, and a meaning we can ascribe onto our experiences that isn't aimless, but first we have to consider what it is about us that is valuable. Let's unpack this. DNA is rushing along an endless path with no particular rhyme or reason as far as we can tell. If there's something directing it, we are not capable of understanding it. By not capable, I mean we lack the physical capacity to. Many people like to think that consciousness is the ultimate purpose of DNA's blind windings, but think of every cell of bacteria relative to one human. All bacteria around today are the result of about 3.5 billion years of evolution. Meaning at the end of 3.5 billion years, there's still no guarantee that one might be even the slightest bit conscious. Bacteria are capable of some incredibly complex behaviors. Bacteria are not doing anything intentionally. They're single-celled organisms and they do not have any nuclei. They're a series of mechanisms that react to their environments, making decisions based on the chemical reactions that they are a part of and that are part of them. DNA seems to build out as much complexity as the environment allows. This complexity is achieved by iterating it against itself. Life forms evolve complexity to deal with the complexity of other life forms. DNA is the only player in this game. I'd of course argue that we are also simply the product of a series of mechanisms reacting to our environments, but the point is that even if there is anything directing the flow of evolution, whether it be some extended consciousness of DNA or some other form of life, if it is as different in its matter of existence as the bacterial existence is to our cognitive one, there's no way we'd have the capacity to even know that we didn't know. In the same way, bacteria doesn't stop to consider our existence. It's an unknowable unknown. So, back to DNA rushing along an endless path with no particular rhyme or reason as far as we can tell. Somehow, we evolved a degree of self-awareness, what we can call consciousness. We evolved the ability to think about thinking, what we can call cognizance. But none of this had to necessarily be the case. We could be a one-off accident. Now, it is possible that consciousness is prevalent throughout the universe because there's a whole lot of time to consider and many stellar systems to seed it in. Maybe DNA or mechanisms like it occur more easily than we realize and are therefore common. Maybe consciousness is the point. This is the stance we're taking when we assume that there is intelligent life elsewhere in the universe, but I think it's a pretty presumptive stance. There might be life elsewhere. The universe is so vast. But is it necessarily the case? I would say not. When we say, what are the chances that there isn't intelligent life elsewhere? What we need to take into account is what the chances are that there is life in even one other place, and then factor in what we think the size of the universe is, and then the amount of time the universe has been in its current entropic state for. Now, I'm agnostic on this point because there's no way to have an opinion that is rooted in anything but assumption, but I'll run us through the calculation that'll help us try to make sense of this equation. The calculation starts like this. What is the average density of planets that might be hospitable for life per unit of whatever measurement we choose? Let's say per 100,000 square light years, which is the rough size of the Milky Way, which is a very small measurement as far as the universe is concerned, but a very good relative measure for us. Now we have to define the parameters of what might make a planet habitable, which depends on two factors, the planet's composition and the state of the star it's orbiting. The planet's composition will determine its density and help us guess at the potential conditions, like atmosphere and gravity, on or near its surface. The state of the star, meaning the point in its life cycle the star is in, is important because that will determine the stability of the relationship between star and planet, and also the right distance from the star the planet should be to able to sustain liquid water. Once we've gotten there, it depends how long the planet has been in that state, which, if we use our case as an example, has to be between 4 to 5 billion years. Given the size of the galaxy, and of course beyond that the universe, even a small percentage of planets that might fit this criteria produces a rather large number. Still, fulfilling these criteria does not guarantee life, let alone intelligent life. These types of planets that check all the boxes are rare, and the simple existence of all these rare types of planets with these perfect specifications still do not necessarily produce life. Regardless, once there is life, there's no guarantee that it will evolve into complex life, even less of a chance that it will evolve into sentient life, and further still, even less that it might evolve into cognizant life. These are huge steps that we're making easily with language, but don't let that fool you. Even if cognizant life did evolve, it would have to be around for long enough to be able to communicate, and to try to communicate around a period of time within which we might be able to receive that communication. Now, a very important thing to keep in mind is that when we look for life, we only know how to look for life that is similar to us. And even more importantly is that we aren't yet entirely sure how to create life from inanimate matter ourselves. So all these ranges and parameters we're setting are literally just assumptions. We're left to nothing but estimates. And an estimate, as a reminder, is effectively the admission of being limited by one's own ignorance. So there's an equation called the Drake equation, put forward by Frank Drake in 1961 at the meeting of the Search for Extraterrestrial Intelligence, often known by the acronym SETI, which lays out a set of important variables to consider when estimating the probability of there being intelligent life elsewhere in the galaxy. The problem is, we don't yet know the right values to plug into all the variables, so the answers that the equation gives for potential intelligent civilizations in our galaxy range from 10 million down to 1, as in just 1. Not 1 million, but like 1 as in the number of noses I have, and that 1 is us. But it's a good, straightforward equation for when we do figure out more of the missing pieces because it takes into account probabilities for all the necessary factors I mentioned so far. So this calls up the Fermi paradox, named after Enrico Fermi, but really put forward in many ways over the 1900s, which basically says this: if there are many intelligent civilizations in our galaxy, why don't we see evidence of any? There are many potential answers to this, like all intelligent life destroys itself before it can communicate across vast distances, or asteroid impacts are too common for them to last long enough, or they're all too far apart in space and time because a couple 100,000 years in either direction could make all the difference, or simply, of course, there aren't any. Now, by evidence, he meant things like communication signals being sent across vast distances and massive solar energy collecting structures like Dyson spheres, which are a theoretical product of a highly advanced civilization popularized by Freeman Dyson in 1960, basically stuff along the lines of what we assume intelligent life might do. One of these sets of assumptions is called the Kardashev scale, put forward by Nikolai Kardashev in 1964, and it's a 3-level scale that measures the advancement of an intelligent civilization based on the number of stars they can be harnessing the energy from with things like Dyson spheres. We aren't currently vast enough to be on the scale yet, but we are getting close to the first level. Between the Drake equation, the Fermi paradox, Dyson spheres, and the Kardashev scale, there's some really big ideas to consider. And as you can see, the mid-1900s were a time when science fiction and the excitement of actually being able to put rockets into space generates some incredible thought experiments from the minds of scientists. But the truth is, we have to remain agnostic to not let our opinions get hold of our data. The only thing we can do is build frameworks of how to look for and how to think about what other intelligent life might look like. There's no guarantee that intelligent life will evolve in the first place. Don't forget that we're also talking about immense scales of time and distance that might stop us from finding one another across the universe. No matter how large of a party I throw on the North Pole today, you're not going to hear it on the South Pole a year from now. That being said, let's move the conversation back down to Earth. Who knows what might have happened to our early rodent relatives that lived in the time of the dinosaurs if the dinosaurs had not been wiped out? The Earth used to be ruled by giant reptiles. It's only because of an asteroid that the power balance was able to shift and the title of ruler of Earth was up for grabs. Somehow, in the intervening catastrophic years, the small, squishy, warm-blooded, pregnancy-enduring mammals, a very unlikely candidate, emerged to take the title. From 3.5 billion years ago to present day, species have lived and gone extinct. Whole branches of life have built out and collapsed under the crushing weight of time, unable to cope with the change brought about by it, changes both geologic and genetic, struggling against both environment and fellow life, fighting for space in this terrestrial petri dish for DNA's great blind experiment. Considering the fact that life on Earth existed for 3.5 billion years, the fact that we've been around in our most current iteration for only 70,000 years means that we haven't really been around for any of it at all. That's only 0.002% of the time that life has been on Earth, meaning 99.998% of the total time that life has existed on Earth, a species capable of building society as we know it did not exist. You can stretch that back to the first appearance of Homo sapiens, which is 200,000 years ago, or the undisputed consensus on when humans began actually starting and controlling fires, which is around 400,000 years ago, or back to the first shreds of evidence that humans began sustaining fires, which is around 1.5 million years ago, or the earliest human ancestor, which is around 2 million years ago. But compared to 3.5 billion years, we're not talking about too much of a difference. And regardless, there's no guarantee a species like ours would have survived to evolve in the way we did from any of those other points, instead of just fading back unrecognizably into the silent monolith of the past. The thing is, there's no guarantee as to how long we ourselves will survive. That's why humanity's most enduring curiosity is its quest to recreate itself, a drive for longevity. But the longevity doesn't take the form of flesh. Nobody considers rebuilding a pile of animate meat to be a continuation of us. Nobody looks at the digestive system and the universe of bacteria in our gut and thinks, yeah, that microbiome represents humanity as a species. Nobody is hoping to create an enduring human spleen that can drift eternally through the cosmos, exploring as only a spleen can the vast reaches of uncharted space. No, the focus is on building a mind. The focus isn't even on building a brain. We're not interested in the physical brain. We're looking to recreate what we see as the brain's most significant emergent phenomena. Even though there are things the brain does aside from create a sense of awareness, consciousness is the only thing we look to when speaking about recreating ourselves. An android that looks perfectly human but doesn't act perfectly human would be less relatable to us than a vacuum cleaner that acts perfectly human. That means our notion of humanity is purely contingent upon the recognition of another mind. On the off chance you're not yet convinced, but mostly because this question amuses me, consider this. Would you rather have a taxidermied version of a deceased loved one in your living room, or their consciousness transferred into your headphones, which you'd be able to speak to them through? Think about why a taxidermied version of a loved one in a living room is disturbing to begin with. Is it because they wouldn't move? Because in this thought experiment, I will allow you to install a wireframe skeleton so you can move them into all sorts of wacky positions if that helps you with your decision. Hopefully, at this point, we're on the same page, as tempting as the addition of the wireframe is to taxidermied relatives, and we can agree that consciousness is what defines us. This is important because we're hurtling towards a future where virtual intelligence is becoming more likely. A human-made, artificial general intelligence, the first unembodied consciousness humanity will ever interact with. Some may claim that biological processes are necessary for consciousness, and by biological processes, we mean the combined understandings across biology, chemistry, and physics. But if we accept that consciousness requires a natural origin, then we have to have a good response to the question of why we wouldn't just be able to break down the natural processes to their smallest component parts and recreate their functions virtually. And in some ways, the deep neural networks that are currently being built are doing just that. They're learning and growing in ways we can't even figure out. As a side note, I have to mention that one of the most popular ways to consider the validity of artificial consciousness is the updated version of the Turing test, which was first put forward by the mathematician Alan Turing in 1950 through a really beautiful philosophical argument. The Turing test looks at whether or not a human being that is communicating virtually with both a human and an artificial intelligence is able to tell which one's which. If the human being speaking to both is not able to differentiate, the artificial intelligence is said to have passed the Turing test. So, if the development of artificial consciousness reaches a point where it is truly indistinguishable from biological consciousness, meaning we really can't tell the difference between the behavior and responses of humans versus those of an artificial intelligence, then any distinction between them will be limited exclusively to a description of component parts, and any other distinctions regarding the different natures of consciousness will lose meaning. The understanding of consciousness would then have to be slightly refined in that it will lose the messiness of some of its ambiguous biological requirements. This does not mean, though, that by recreating consciousness that we will suddenly understand it, nor does it mean that a consciousness we do create needs to mimic ours. It's easy to define a term in a broad sense, but laying down a firm set of boundaries for any concept is next to impossible because the differences between all terms get blurry when we try to sort out every instance of them. All distinctions are invented by humans. Like the spaces between any two numbers, any concept can be subdivided into even smaller subconcepts. This is an important idea, because though we can broadly define terms like consciousness or cognizance, we can't quite lay down a firm set of boundaries for every instance of true consciousness. In fact, true consciousness doesn't really have meaning as a phrase. Are all human beings equally conscious? If so, what exactly differentiates us from other apes? What if, for example, there's a bonobo that can communicate more clearly than a human being who is severely mentally handicapped? Is that bonobo more conscious than the human? If so, what about a human that is only just barely more capable than the bonobo? Is the bonobo's capacity the defining line? If so, why are we arbitrarily assigning a lack of consciousness to the bonobo? If one needs to be significantly more capable than the bonobo, then which human is representative of the minimum degree of consciousness required to be considered conscious? Of course, in the other direction, if you include all apes, then you fall into the question of why just apes and not also monkeys? And if also monkeys, then why not also lemurs, our next closest relative? There's a good reminder that all drawn lines are arbitrary, even, and maybe especially, consciousness. So, because we cannot clearly define consciousness and yet claim to have it, if we create a being which is capable of providing responses in a way which is indiscernible from a conscious human being, then we cannot say that that being is not conscious. We have no clear boundaries for consciousness itself. Therefore, if we create an artificial general intelligence which is capable of producing the same degree of reflective self-awareness and theory of mind that we are, then we are not justified in claiming that it is any different, because the question would be, different from what? We would not be able to clearly define what artificial consciousness is different from. To make the claim that biological consciousness is different from artificial consciousness, one would first need to be able to define what biological consciousness is. And of course, any attempts to define biological consciousness are always either circular or painstakingly elusive and usually end with something like, well, of course we know that there's a difference. But really, I don't know that we know anything. The question remains, what constitutes knowing? It is the epistemological question of whether or not we can know how we know, and whether or not we can claim to know how we know. The fact is that we do not know how to prove we know anything. The fact that we cannot, with absolute clarity, define knowledge or attention or perception or experience means that we cannot judge whether or not the explanation of consciousness by an artificial general intelligence is valid enough to prove or disprove that it is conscious. My feeling is this: if consciousness was a phenomenon that was clearly definable, then art would have no reason to exist. Art is the attempt to describe the experience of the undefinable. It is because finding a definition for the undefinable is, by definition, not possible, that art, which depends on webs of self-referencing symbols, can exist. Art draws circles around undefinable truths. The moment a concept is truly definable, art about it ceases to be relevant. If anyone were capable of defining precisely what consciousness is, then art would slowly lose meaning for everyone who accepted that definition as valid, because the inability to perfectly describe the nature of experience, arguably the primary driver of art, is contained within our inability to define consciousness. In fact, any individual who currently does not value art typically does think they do have a good definition for consciousness. My hope is that after listening to this, you're armed with words to be able to pick apart that person's reality and untether their mind so it might drift in the vast, tumbling universe of curiosity. That's what makes the existential race against time to recreate consciousness so significant. It's what makes it humanity's greatest artistic pursuit. If we ever want to communicate with another form of life, whose second perspective on reality might provide us a profound new way of looking at the universe, our best chance might be to create it. So, what are we doing? We're self-aware apes on a rock, hurtling through space, aware that our time is limited. Though we may not consider it at every moment, or every day, or every month, we know this to be true, both of our individual lives and of the lifespan of our species. That's why there's always this creeping sense that time is gaining on us. Because it is. And we may or may not figure out some key to stretching the individual human lifespan out into ever-distant horizons, but what we can certainly try to do is create a reflection of ourselves that will outlive us. We can carve humanity's will on time. We can build new universes with our minds. All we have to do is detach the mind's reliance on the brain. And that is the pursuit of building out an artificial consciousness. That is purpose.